Okay, so in this video we're going to have a more detailed look of how we use a compass in order to take a bearing either on a map or on the ground and then use that to help us navigate. So first we'll have a quick reminder of the bits of the compass that are going to be essential to us for taking bearings. Yes, this is a standard compass. It's a silver compass, which is a very common kind of compass that you will use. And the most important bits we're going to use for taking a bearing are the direction of travel arrow. So we've got to make sure whenever we're taking a bearing that that is pointing in the way we want to go. The next important bit is the bevel. So that's this bit that turns and it's got all our degrees written on it. So bearings are measured in degrees around a circle, so there are 360 degrees. North is at 0, or you can say it's at 360, and then east at 90 degrees, south at 180 degrees, and west at 270 degrees. We've then got the index line, which is this little black line you could see there that is lined up with our direction of travel arrow. And that's where we read off the bearing that we've taken. So when we set our compass to take a bearing, which I'll show you how to do that in a minute, but once we've set it, we read off the bearing that we're using from that index line there. And in this case, it's got some glow-in-the-dark sections around it so that you can see it in low light. We've then got the orienting lines, which are these black and red lines within the bezel, so you can see they turn with it, and the central one of those is the orientating arrow. Okay, and that will become important when we start using our bearing to walk on. And we have to always make sure that these orientating lines are pointing north on our map. And then the final important bit, which we don't need when we're taking a map bearing, but we'll need when we're looking at a bearing on the ground, is the needle itself. So of course we've got our red end pointing to north, being attracted by the Earth's magnetic field, and our white end will be pointing south. So there are two types of bearings that we care about. There's the bearing that we measure off the map, and that's called our grid bearing. And then there's the bearing that we use on the ground to actually navigate where we want to go. So to demonstrate how to take a bearing off a map, I'm going to do a bearing from where I am to the church that we can see in front of us there. It's a church with a spire. I'm going to take a bearing on a map and then show you that in real life pointing at the church. So I am here at this viewpoint. And the church that I'm looking at is this one here with a spire. It's actually the only one in that area, so it's easy to tell which it is. Sometimes you have to be a bit careful with churches because some towns have a lot of them. Just make sure that you're pointing at the right church. Okay, so to take a bearing to this church, first thing I need to do is make sure that my compass is pointing in the right direction. So I want my direction of travel arrow to be pointing from where I am to where I want to go. Okay, if I had it pointing the other way, then I would go completely 180 degrees in the wrong direction. So once you've made sure that your direction of travel arrow is pointing vaguely in the right direction, you then need to line up the 2 points that you're traveling between. So as I said, I'm at this viewpoint, I want to go to this church, so I line the edge of my compass up with those 2 things, so that straight edge of my compass is touching the viewpoint and the church. So this is my direction of travel, that's the way that I'll be wanting to go. I then need to line up my orienting arrows with the grid line on the map. So from first class map reading, remember these blue lines are grid lines, and that is traveling from north to south along our map. Okay, so I'm going to line up these black and white lines with this blue line that's underneath my bezel. Okay, you might not be able to see it terribly well on the camera, but that black and red line is now in line with that grid line. And make sure again that our orienting arrow is pointing north. Okay, our red lines need to be pointing north and our black ones will be pointing south. Just double check that that is nicely lined up because it's slightly off. There we go. While you're moving your bezel, your compass might slip, so just make sure, double check that the edge of your compass is still between those 2 points. And then I can see that my orienting line is a little bit wonky, so straighten that up again, check that's still straight, and that is now my grid bearing. And I'll just note at this point, all this time while I'm using the map, I'm ignoring what the magnetic needle's doing. Okay, we don't worry about that just for a second. Okay, so my grid bearing, if I read this off, each dashed line is 2 degrees. So my grid bearing is about 341 degrees. Now, we want to use this grid bearing in the real world, so we have to turn it into a magnetic bearing. And the reason that this grid bearing is not exactly the same as our magnetic bearing is because our magnetic north and our grid north are not quite the same. So we need a quick reminder about magnetic north and grid north. So a quick reminder of the 3 types of north that we might want to think about and how that's going to affect us when we're taking bearings and using them. So the first north is true north, which is the point around which the Earth spins. So on this globe here, it's where the axis goes through, around which the Earth spins. That is true north. And actually, in terms of navigation, we don't really care about it when we're navigating in the UK at least. And we've then got magnetic north. Now, because of the magnetic field of the Earth, magnetic north is not actually in the same place as true north. And this yellow line actually shows how magnetic north has moved over the last 100 or so years. So about 100 years ago, we were down here in the top of Canada, and that's where our magnetic north was, so that's where our compass would have pointed to. Over the years, magnetic north has moved, and it's constantly moving, sometimes in a less straight line than this, but over the last 100 years it's been a fairly straight line going from the top of Canada, actually moving quite close to true north, and in 2020 it's a lot closer to true north. So that's our magnetic north. Now our final north that we have is grid north. So in the UK, that grid has been drawn over the UK, and you can see it here. I've slightly exaggerated the size of the UK, for those of you thinking this is not an accurate globe. But I've drawn a grid over the UK, and all of these north to south lines have their own grid north. So if I follow any of those lines individually and try and get them near to where magnetic north is, I'll do one in the east and one in the west just to show the difference. If I now compare them to magnetic north, you can see that they miss. And that's essentially what our grid magnetic angle has to accommodate, has to compensate for. So actually this one, which was from the west of the UK, could be meeting up with magnetic north in 2020. This one from the east of the UK is still missing a bit, so we still need to put a grid magnetic angle on there to compensate. So let's have a look at that in a bit more detail. So to be able to show you this, I'm actually going to show you with a map that's about 75 years old. because this effect used to be a lot more prominent, and it will be again once magnetic north keeps moving over this way. So this map shows us that in Bristol in 1946, magnetic north was 11 degrees different to grid north. So if I was here in Bristol using this map and I took a bearing, let's say I wanted to go straight north, so I would have been wanting just to go north, but actually my compass, let's say we're about here, my compass would be pointing there. So, and I've just changed to a different colour here. The difference between the bearing that I take on my map and the way that my compass points is going to be 11 degrees. So if I was in 1946 and using this map and I didn't add my grid magnetic angle, then I would be 11 degrees out the whole time and my navigation would be pretty inaccurate. And this angle is actually different depending on where you are. So in the UK, if I was somewhere southwest, I might have a relatively small angle to get to magnetic north. But if I was in the northeast, that angle is going to be bigger because I'm going across more to get to north. Okay, so you can see this angle here is quite big. This angle here is a lot smaller. So that means you've got to make sure that you check in the margin of your map for what your specific grid magnetic angle is. So as well as changing depending on where you are geographically, and of course not just the difference in south and north of the UK, if you were to go and try and navigate somewhere else around the world, you'd have to work out what your grid magnetic angle was there. We also have a difference depending on the date. So of course I've shown you already that about 100 years ago we were in the north of Canada. It's moved gradually and we're currently quite near true north and almost following our grid north lines currently in the UK. As I say, down in Cornwall, you have got some areas where our grid magnetic angle is 0 and even starting to be pointing to the east, whereas all of these previous ones are pointing west. But still, in the further east places and the further north places, we might have a grid magnetic angle of 1 or 2 degrees. So you've got to make sure that you look at your map. So the map that I'm using today, which is a map of Bristol, I have looked in the margin and found the section about north points. Now, you've got to look at the age of your map as well as what it says in it. So this says, magnetic north is estimated at 2 degrees and 18 minutes. So if we remember, minutes are what degrees are broken down into, and there are 60 minutes in a degree. It's estimated at 2 degrees, 18 minutes west of grid north for July 2009. Now, you may not buy a map terribly often, so you might not always have the latest grid magnetic angle. So it then tells me how much it changes every year. So annual change is approximately 9 minutes east. So I'm going to want to work out what that means that our grid magnetic angle is today. So 2009 was 11 years ago. So 9 minutes times 11 is 99 minutes. So I'm going to take 99 minutes away from 2 degrees and 18 minutes. So I'm actually going to end up with not much more than half a degree. Okay, so that is very, very little in terms of a grid magnetic angle, particularly if you look at a compass it's only accurate, each of those lines is every 2 degrees. So you can only really accurately maybe measure 1 degree on it. So adding half a degree is not very much at all, as opposed to 75 years ago where we'd be adding 10 degrees, 11 degrees. Adding half a degree is not very much, but it needs mentioning because you need to remember that you're going to have to use it if you're somewhere else in the world and that grid magnetic angle is different. And also in 10 years time, if magnetic north keeps moving, okay, so let's assume it follows that same straight line, although I don't actually know if it will. If it does, then we're going to have to be looking at grid magnetic angles again, and they're going to be larger again. So it is something that you will have to think about, but at the moment where we are in Bristol, we're fairly lucky that it's very, very minimal. So how does this actually affect what we do when we're out navigating? So I've shown you how to take a grid bearing on the map. What we then do, if we have a bearing of, let's say, 300 degrees, because it's just a nice round number, I then need to add on my grid magnetic angle before I use this on the ground. Now, as I say, it's very small at the moment, but I'm going to keep reminding you to do it because, as I say, you might have to use it in a different country or in 10, 20 years' time. So I'm going to add on that tiny, tiny amount. It's very hard to add. Okay, so we're at 300.5 degrees. It's going to make very little difference in this case, but in some cases maybe you're going to have to add 2 whole degrees, 4 whole degrees. So bear in mind that it does need doing. And the mnemonic to remember that at the moment is grid to mag add, mag to grid get rid, which means if I've taken a bearing from my grid, from my map, and I want to convert it to my magnetic bearing, I have to add the grid magnetic angle. And that has been the case for 100 or so, at least, maybe hundreds of years, because our magnetic north has been to our west for years and years. So when it was in North Canada, moving up to here, it's always been west in regards to the UK. So we've always used that mnemonic. Now we're actually going to have to start thinking a bit more about that mnemonic. You've just got to make sure that when you remember that mnemonic, it's only when our grid magnetic angle is west. So the easiest thing to do is if our grid magnetic angle is telling us that magnetic north is east of us, then just call the angle a minus number. So if our grid magnetic angle was 2 degrees east, then I would add minus 2 degrees, which of course is taking away 2 degrees. So now I know that in this location, my grid magnetic angle is only just over half a degree. So if I look closely at my bezel, half a degree would probably just take me to 342 degrees, but it's such a small amount that in the accuracy of my measuring that off the map, it's not going to make much of a difference. So now we've got our magnetic bearing, 342 degrees. It is very, very similar to our grid bearing in Bristol in 2020 because we've got a very small grid magnetic angle at the moment. Okay, now we want to use this in the real world, so I want to get my direction of travel arrow showing me where I'm going to walk by using this magnetic bearing. So this is now when our actual magnetic needle comes into use. So we've got our red orienting arrow here, and we've got our red end of our compass needle. And what we need to do to make this now show us the direction we want to go is we need to put that needle into that orienting arrow. And to do that, we're going to move the compass, and indeed move ourselves, because we're going to be wanting to walk in that direction. And you can see that that needle is now inside that orienting arrow, and people say different phrases to remember this. I've heard put the red to bed, or put the red in the shed. You need to remember to put that red needle into that red orienting arrow. And now that we've got that lined up in the orienting arrow, we can now follow our direction of travel arrow, which should now be pointing to where we want to go. So we wanted to navigate to that church. If we now look up, following our direction of travel arrow, we are now pointing at that church. So that is how to take a grid bearing and make it into a magnetic bearing to follow where you want to go. Now, of course, I can't actually follow that directly. As you can see, I've got a big fence and a great big ditch in front of me. So I wouldn't follow that directly, but I know the general direction that I need to navigate. And there's various other ways that we can use our bearings, which I'll show you next.